Hi everyone, my name is Anthony Ramirez and I'm a cloud engineer at Nebulaworks, and today we're going to talk about container security. The objectives of today are to describe the motivation for a project called the Update Framework, or TUF. We're going to describe Notary, which is an implementation of TUF, and then we're going to look at an example of how you can use Notary with the Docker platform. So off the bat, TUF and Notary are open source projects that are part of the Cloud Native Computing Foundation. So these tools are open source and they have open source communities that are driving the motivation for new functionality and new features. So before we get started, these are the tools that we're going to be discussing today. It's going to be TUF, Notary, and the Docker platform. There's some assumptions about the knowledge that you have about Docker, since Notary and TUF provide mechanisms in order to securely update Docker images. So at this point, it's assumed that you're familiar with writing a Docker file, building it, tagging it, and pushing it to an image repository. So the Update Framework is a project that was started in order to create a generic framework that secured software update systems. So there exists dozens of software update systems on your computer which provide the ability for software to update packages in order to either remove vulnerabilities or add new functionality. So there's a need to better understand how the updates to software should be managed. So the Update Framework intends to provide a framework that can be used to secure new and existing software update systems, to reduce key compromise so that the entities that are signing your keys are authorized and are who they say they are, and should be generic enough to be compatible with many systems, in this case, the Docker container platform. So Notary is an implementation of TUF. So under the covers, Notary is essentially the TUF framework, and Docker introduced Notary in 2015 along the concept of Docker Content Trust, which is the ability to sign your images and push them to your repository and verify that the entity that signed and pushed your images are who they say they are. So now we'll get into an example of how to implement Notary and Docker. So on this side we have a list of things that we're going to be discussing, but at first I'm going to describe some of the components that are necessary in order to integrate Notary with Docker. So first, we have a local workstation that's running the Docker engine that's greater than 1.8, and this is a local workstation that our developers on. Over here we have an image repository that allows us to store our images. And we have a Notary server and signer. So this is the server, signer, and we both have some databases here. So the first thing that you have to understand is that Notary provides you the ability to authenticate what content has been updated, by who, and when. So considering that these are some features that Notary provides you, it's important to define how to leverage the features correctly. And so to do that, we're going to define the key hierarchy in Notary. So I'll describe this at a high level, and you can find more information by going to the updateframework.com. But at a high level, we have a root key, which is in charge of establishing the root of or source of all truth for all of the content and metadata that you'll be trying to verify. From this key, we'll create a timestamp key, which provides us the ability to sign with a timestamp to guarantee freshness of the content that we're modifying, pushing, or pulling. There's a targets key that's responsible for delegating a specific content. In this case, we're talking about an image repository that a signer will be able to interact with, and then there is a snapshot key. And the snapshot key allows you to create a point-in-time snapshot of all of the content that exists and changed within a image repo. And then from a target key, we have the ability to create delegations. And a delegation is essentially a way to allow a user, such as a Docker engine, in order to interact with the repo. So the purpose of creating this hierarchy in this way is that if a delegation key is compromised, it's very easy to regenerate these keys. And since these keys can be used for automation purposes, most of the time they might be online or accessible through a web server. So these keys should be treated almost as ephemeral, and then the root key, or also known as the offline key, should be kept safe, and it is very hard to recover from losing the root key. So first and foremost, you have to initialize and configure Docker to use Notary. So another component that must exist on this host, so if this is the developer workstation, we also have to add the Notary client. So the Notary client, or the Notary CLI, will exist on this machine. And what we'll do is we'll connect or make this Notary client aware of this server and signer. And technically, all of this can run on a single host if you wanted to create a proof of concept or an MVP. However, for production purposes, it's not recommended. You should have Notary running in a secure network, possibly in running on different servers. You can also run Notary with containers. So there's a GitHub repo that provides you the Docker Compose files to stand this up. So we have a Notary client here that communicates with the Notary server through configuration files. Then, in order to provide the Docker engine with instructions in order to use Notary, we export an environment variable called Docker content trust, and we set it to 1. So when this variable is set to 1, the Docker engine will automatically look for a key. So you may ask, well, how do I generate this key? In order to do that, you must run a command called notary init and then a repository. So this is a shorthand syntax here, but normally you would have to provide the workspace of the repo and then the actual repo name. So once you initialize a repo, this repo now has content trust metadata. So every time I push an image to this repo, the Notary server will verify that the key that's used to sign the image exists, and it will verify all of the content that you're pushing and allow you to push to the image repo. So essentially, the keys that we're using here, if we're using a delegation, is a user's public and private key pair. So the user holds on to the private key, and Notary holds on to the public key. So now if there are any pulls back to the engine, we can verify that the public key that exists in the image repo matches the private key on the Docker engine. So with this workflow, developers can first configure the Docker engine and Notary client, and then enable Docker Content Trust by exporting Docker Content Trust to 1. And then every time they build, tag, and push an image, it will require that a key be present, leverage that key to sign the image, and then push it to the image repository. And then when you pull that image, it will verify with a public key. So the point of this is to ensure the integrity of the users that are pushing any updates or content to your images, as well as provide mechanisms like a timestamp key in order to guarantee the freshness of these any updates to your images. So at a high level, we discussed the update framework, which is a tool, an open source tool created to secure update systems. And Notary is an open source project that leveraged TUF in order to verify the integrity of users that are pushing Docker images. And then we talked about how you can use these tools in tandem with Docker in order to sign images and verify who either pushed or pulled from a repo. Thank you for listening and watching. If you enjoyed this video, please like and subscribe to our channel. And if you want more information about container security, signing images with Notary, please visit us at nebulaworks.com/contact us. And also check out the links in the description if you want to know more about the tools discussed today. Thank you.